Hello everyone. In this video I'm going to speak about pH curves, strong acid, strong base titration. A very important announcement before starting our lesson is that you have to return back to the previous video to understand how the titration is happening or how we calculate the pH during the titration. Let's start our lesson. If we have 50 cubic centimeter of this concentration, 1 hydrochloric acid, with 50 cubic centimeter of this concentration sodium hydroxide solution. Before any of the NaOH is added, so we have in our flask only hydrochloric acid, so the concentration of the hydrogen is equal to the concentration of the acid, which is 1 mole per cubic decimeter, so the initial pH is equal to 0. What if we add 49 cubic centimeter? After the addition of 49 cubic centimeter of sodium hydroxide, there will be only 1 cubic centimeter of this concentration, which is 1 mole per cubic decimeter HCl remaining in 99 cubic centimeter of solution. We can say that it is 100, it will not make a big change. So, amount of H plus remaining in 100 centimeter cube, as we said last time in the previous video, that we have to find the number of moles first of the hydrogen ions, then we can calculate the concentration, then from the concentration we can calculate the pH. So, number of moles of hydrogen ions equal to C by V, so the concentration of hydrogen multiplied by the volume of hydrogen. We have the concentration of the hydrogen is 1, and the volume of hydrogen left over after neutralizing 49, because 49 of the sodium hydroxide had already neutralized 49 of the acid. So the leftover is 1 divided by 1000, because we would like to find our volume or to make our volume in cubic decimeter. So we will have this number of moles, 1 by 10 to the power negative 3. Then the concentration of hydrogen will be N over V, number of moles that we have calculated, over the total volume of the solution, which is 100 by 10 to the power negative 3. Then we have the concentration of hydrogen, and the pH will equal to 2, negative log the concentration of hydrogen ions. Okay. You can do this yourself. So you can pause the video here, then you can continue after calculating it yourself. Okay, let's say that you have, after addition of 49.9 cubic centimeter of sodium hydroxide solution, there will be 0.1. Why 0.1? Because, as we said, you have 50 acid. You add 49.9. So what is the amount of acid which is left over or did not have not been neutralized? It is 0.1 cubic centimeter. Okay, again, calculate number of moles of hydrogen remaining in the solution, and after that we can calculate the concentration. So N is equal to CV, concentration of hydrogen by the volume of hydrogen. Concentration of hydrogen is 1 by concentration of hydrogen is 1, but the volume is 0.1. So this is for the volume. This is for the volume, 0.1. And we have here 1 all over 1000, because we would like to have the volume in cubic decimeter. So this is the number of moles. Then the concentration will be N over V. Then we'll get this concentration, and the pH is 3. So we can observe the pH change from adding 49 sodium hydroxide to 49.9. Very small change. What if we are adding 50.1? After the addition of 50.1, what will be produced? This is what we should calculate now. Again, we need to check what is left over. What's left over here is 0.1 cubic centimeter NaOH. Why? Because in the flask we were having 50 cubic centimeter acid. So after adding base 50.1, so there is 0.1 left over will be in the solution. Okay, remaining in 100.1, let's say that 100 centimeter cube of a solution. So we will calculate here the concentration of OH, which is N over V. N is CV for NaOH. We already know that the volume is 0.1. We convert it to cubic decimeter by multiplying it by 10 to the power negative 3, and we have the concentration all over the total volume of the solution. Then we'll get the concentration of OH. We can find POH negative log OH negative. Then we can, of course, find the pH, which is 11. Can you see the difference from 49.9 to 50.1? A big change in the pH. A big change in the pH. So just like half drop, or we can say a drop of base could make this sudden change. Let's check the graph. As you can see here, this is the pH curve for strong acid, strong base titration. It is clear that we are starting our titration from a low pH value, which is representing a strong acid. So pH 1 at the start, because we have 0.1 molar HCl, strong monoprotic acid. Very little pH change after adding some base during the initial 20 cubic centimeter. Very sharp change. There is a very sharp change in the pH over the addition of less than half a drop of NaOH. Then the curve levels off at the pH 13 due to excess 0.1